We are talking about equations and inequalities involving absolute value expressions today. An absolute value measures distance, and as a direct consequence of this is that it can never be smaller than 0, or in other words, it can never be negative. How to solve equations involving absolute value bars? Well, the first thing that we are going to do, we isolate the expression with the absolute value bars. That is the same thing, the process that you have done when you were isolating your variable first. Like you subtracted things to move things from left to right, or you added expressions, terms. Now, the second thing, after I have isolated my absolute value bars, I'm going to be using the definition if U is some algebraic expression, that means something with an x involved, and C is some positive number, then if I have my absolute value bar here on the left side isolated, it's alone, there's nothing in front and nothing behind it, and it is equal to some positive number here on the right side, then I can open up my absolute value bars and I'm going to turn this into two separate equations that it is either equal to the positive C or the negative of that number. These two equations then have to be solved separately. Let's look at a concrete example. So we want to solve the absolute value of 2x minus 1 is equal to positive 5. Now the first step I do not need to worry about because my absolute value expression, this part right here, is already alone and isolated on the left side. That means what I have to do now is simply taking this and I will turn this whole equation into two new equations. 2x minus 1 is equal to 5, the same equation without the absolute value bars, or 2x minus 1 is equal to negative 5. These two equations now I'm going to be solving, and the answer to those equations will be the solution set to the original problem. So what am I going to be doing? Let's first solve the one on the right side. So I'm adding 1 to both sides. I get 2x is equal to 6. Now I will divide both sides by 2, and I get that x is equal to 3. On the right side, the equation, I'm doing the same thing. I'm adding 1 to both sides. And I will get, well, a negative 5 plus 1, that's a negative 4. And I will also divide by 2. And I get that x is equal to negative 4 divided by positive 2 is a negative 2. So my solution set, my solution consists out of two numbers, the number negative 2 and the number positive 3. And I can test this. I can check whether I did this right. If I first check x is equal to 3 and I plug this into my equation, then I end up with the absolute value of 2 times 3 minus 1. Well, and I'm trying to find out whether this is really equal to positive 5. On the left side, I work from the inside to the outside. 2 times 3 is 6, minus 1. And you see already, this is going to be 6 minus 1 is 5. And the absolute value of 5 is indeed 5. Now, if I check the second number, I'm going to be checking x was, what was the other solution? 2, negative 2. I'm going to be doing the same thing. I plug this in. I had 2 times a negative 2 minus 1, and I want to see whether this really is positive 5. Working from the inside to the outside. 2 times a negative 2 is a negative 4. We are testing So this is going to be the absolute value of a negative 5. And yes, indeed, absolute value bars, all what it does, it makes something positive because, as I said at the beginning, it represents distance. Let's do one more. Now, for this example right here, I have to do a little bit more because my absolute value expression is not alone. So, the first thing I have to do is first isolate. I am taking the negative 28 and I move it to the right side. So I will get 2 times the absolute value of 1 minus 3x, this is the algebraic expression, is equal to 28. Now, I still have multiplication. Do not multiply this in as if the absolute value bars are parentheses. You cannot necessarily do this. What I can do is divide both sides by 2. This 2 now cancels out, and I have the absolute value of 1 minus 3x is equal to positive 14. Now the steps are identical to the problem from before. So, I'm going to turn this into 2 equations. The equation 1 minus 3x is equal to 14, or 1 minus 3x is equal to negative 14. And I solve both now separately, subtracting 1 from both sides. I'm getting a negative 3x is equal to 14 minus 1, that is 13. And now I divide by both sides by negative 3, and I get x is equal to, well, 13 divided by negative 3 is just simply negative 13 thirds. On the right side, I do the same thing. I subtract 1 from both sides. I get a negative 3x is equal to negative 15. I divide by negative 3. Now the right side turns into something a little bit nicer. Negative 15 divided by negative 3, that is a positive 5. So my solution consists out of the 2 numbers, a negative 13 thirds and positive 5. I could test this again, but I rather would like to go to the next problem.